they're observing the vulnerabilities, and they're taking action. What is the antivirus vendor doing? They're observing what the attackers are doing, and they're taking action. Even with daily updates, you're going to be 333 Kubernetes variants behind because of the volume of new malware that the attackers are able to distribute. It's coming at a rate that the antivirus companies basically can't keep up. They have to pick and choose what's the most popular malware to write signatures for. Because there's certainly a lot more attackers, and it seems like they're able to do things a lot quicker than the defenders are able to do. I guess we can see that. So, some data that just came out in a very interesting article this week. It was an information week called, I think it's called Epic Fail. It's by Greg Shipley at Neo-Apsis. And one of the statements in there was they did testing and they said bypassing 5 major antivirus suites was a trivial matter. Now, this isn't because the antivirus companies have bad engineers. You know, it's not like they're writing buggy software or they're incompetent. It's just the model is fundamentally broken. They're not able to react fast enough. The attackers have gotten inside the OODA loop of this reactive security model of trying to react to a new piece of malware. The other thing that I think the attackers are doing is they're laying low so you can't even observe. The antivirus vendors can't even observe with their sensor networks some of the malware because it's very custom and it's only being used in small population samples. Or maybe it can be observed and it's just low on the priority list to write signatures for it. In the 2010 Verizon data breach report, 54% of the malware used was custom. So again, this is something that is basically breaking this reactive model. If it's custom and only used in a few places, how can you react to it, right? And this isn't just antivirus. There's other layer defenses that have a reactive model to them, right? IDSs and IPSs. They typically only work if they have knowledge of attacks. So the attack has to exist first before they have knowledge of that attack, or the exploit with the proof of concept attack has to exist first. So Neo-Apsis did a survey of 2 months worth of CVEs. It was about 1,400 CVEs, and they tested the IDSs, and they found that they were covering 20 to 30%. Now, there's probably a good reason for that. Writing 1,400 signatures in 2 months would be a huge engineering task, right? They can only do it for the most popular ones. There's just too much volume of new vulnerabilities being found that they have to react to. So again, fast food to life, slow to death. And I think that we're in that point now where the attackers have gotten inside of our OODA loops, and reactive models aren't working anymore. They might have worked 10 years ago when the technology was introduced. People started buying it. But the thing is, they keep buying it. Now, just to look at, let's look at some of these models. With Wi-Fi, it's basically, it's a networking protocol. It's in a lot of hardware. There's, client-side hardware, access point hardware. There's a lot of firmware out there. This stuff just isn't easy to update. It's just not easy to change once the technology is out there and it's being adopted for a few years. So Wi-Fi basically hasn't fundamentally changed, over its lifespan. I think the only thing that happened is, we got a new encryption algorithm, WPA2, which you can't use everywhere because maybe people haven't updated their access point to support it because they don't know how. And that's sort of the problem with, the technology being kind of frozen. But of course, there's other kinds, the free public Wi-Fi problem really hasn't been solved either. Web apps with SQL injection, there's sort of new applications with this vulnerability being written every single day. And I think the reactive model here is a organization like, say, Heartland gets broken into in one of their apps. They realize they have a huge gaping problem. They've developed all these apps, or they've outsourced these apps, or they've installed open source apps, and it's riddled with SQL injection. And they sort of see the light because they have this huge break-in, and now they're going to go around to fix all their applications. That's typically what I see. There's a huge break-in, and then they decide that it's worth investing now. So that's obviously an extremely slow reactive model. Windows Trojans, we have antivirus. We have antivirus technology, and that's how we're dealing with that problem. Mobile apps is really kind of still up in the air. Because we haven't really been through the whole curve yet of adoption, and we haven't had attack automation yet, and there's really no mandates yet. So it'll be interesting to see what happens there. Just a cartoon I found, which kind of talks about the reactive model. It's obviously takes a long time to build a fence along your border that's 20 feet tall. And if an attacker can just put a 21-foot fence next to that 21-foot ladder next to that fence and get over, I think this kind of sums up the problem here of the attacker advantage of deploying technology that has a fundamental problem. So obviously you wouldn't want to just rely on a fence of a certain height if that's your only protection. I'm not saying that that's the only protection of the U.S. border between Mexico, but let's hope not. So I want to make the point that I think it's time to stop investing in reactive technologies once it becomes totally clear that the attackers have gotten faster. So if there is a response component to the security model, the way you're going to protect your systems, then you have to look at how effective it is, and you have to retire it when it becomes ineffective. The problem is, we're not retiring any of this technology. And I wouldn't say, you need to just totally get rid of it, but we keep buying more slightly better versions of all this stuff that's a little bit faster, has a little deeper inspection, or it has a bigger signature set, covers a slightly different class of problem. Because what that does is it crowds out other solutions. It gives that false sense of security that I'm covered, even though it's not really working. And of course, it takes a lot of money to maintain these layered defenses, manage them, patch them, look at the logs. That takes the security staff away from perhaps actually really trying to solve those core problems. So I like to put forth the notion that the future of security is defect prevention. Because once these fundamental design defects get out into the marketplace, they have a lifetime of a decade. Basically, as long as that technology is still used, until that technology is supplanted by something else. And reactive models that are just going to react to the individual attacks that take advantage of these fundamental design problems may start working in the beginning, but over time, the attackers will learn, and they're more nimble, and they will be able to defeat those reactive models. So, how is this going to work? How are we just not going to how are we going to do the security prevention? or default.